Hello friends, welcome back to this series of Windows programming, and we are discussing about the kernel objects in the Windows. So in this series, now we have reached up to the semaphores. So in the previous video, I have just concluded the mutexes, and whatever I have concluded about the mutexes, that is sufficient for you to understand. So if you have understood the basic concepts of kernel objects using by looking into the videos that I have shared, then you will not face any problem whenever you will create any application and whenever you will write any code in C++ using the kernel objects. Okay, so today we are going to discuss about the semaphores. So first let us understand what is a semaphore. Semaphore is basically used for resource counting and synchronizing the access accordingly. Okay, one example can be like you have a single printer, and there are a number of jobs which are coming there, and if you say that there are only 20 jobs that I can handle at the time, and apart from 20 I cannot handle at a time. So in that case 20 will be the resource count that can be considered as a resource count available for the users, right? So at a time 20 users can send the request to the printer, which printer can queue and one by one can print it. If 21st message comes or 21st request comes, then in that case it will not accept it. The other application can be like you are writing a server where it's a socket based server, suppose, and it's accepting the client connections. Maximum it can accept 20 connections. Suppose you are writing that considering the workload, the load on the system, you are accepting only 20 connections at a time. So this 20 connection will be the resource count for your server application, and you will synchronize this resource counting between the different threads. Right, the other application where we can use it can be like reader and writer. There can be one writer and there can be n number of readers. There are n number of readers and there is only one writer. So all these readers who are reading the things which has been written by the writers, what will happen? There are a number of things which will be done at the same time. When the reader is reading, then at that time the other readers can be allowed. It cannot be like if you are reading then other reader cannot be allowed, because it is a reading process. So whatever you are reading, the other person will also read the same. So you can just you may just want that at the time of reading the resources available, I mean the number of people who can read it are 20 or 25 or 30, right? So in that case what you can do, you can simply use the semaphores to make it available. But at the same time, if reader is also there, then in that case what you can do, you need to use the mutex, right? So every thread, every reader thread, we first need to check whether the writer thread is writing or not. If writer thread is writing, then in that case every waiting thread, every reader thread which is waiting for the write to complete, it cannot go ahead to read the contents from the file. So this application, this simple program, I will show you that how you can create it, but today I'm just going to show you that how you can initialize a semaphore and what are the various conditions to initialize a semaphore. Okay, so I hope you might have understood that how the semaphore is used for the resource synchronization for resource counting. Okay, so let me just create one handle for the h semaphore. So h semaphore is null. I'm just creating a semaphore variable here, so I'm just going to initialize it. H semaphore is equal to create semaphore. So here I'm just again the first argument is the security attribute, which is null, and the second argument is the initial count. Initial count says how many maximum resources are available, right? Suppose I say there are maximum number of 5 resources which are available, and initially initial count means initially how many of them are available. So I say that initially 5 are available, and the next argument is the maximum number of resources available. So suppose I want to say that yes, I have 5 and I have all of them 5 are available. So in that case I can provide both as 5, right? So maximum count and the initial count, those are both are 5. So it means that initially maximum 5 resources are available and 5 of them are available in actual, right? It can be like I have 10 resources but only 5 resources are available. So in that case only 5 threads can be scheduled, not the 10 threads will be scheduled. But if I write like 5 and 5 are waiting on them, then all of them will be scheduled. And here I'm just going to give the name text, and I have just given the name underscore sem, right? So this is the name I have given, and now what I will do, I will simply write like if hsem is not equal to 0, same thing which I have done earlier for here I need to use error, int err is equal to get last error. Okay, so this is the one that which I want to do. Error is not equal to 0 and error is not equal to error already exists. Okay, so error is not equal to 0 and error is not equal to error already exists. So in that case, what will happen if these are not the return codes, then which means that I'm not able to create the semaphore. So I will simply print a message here, semaphore not created. Okay, so semaphore not created. I will simply return from here, return exit failure. So that's it. And here what I will do, I will simply use like release. You can simply close the semaphore once you are done. Close semaphore. Oh my god, what should I do? Semaphore. See what is happening? Close handle. I have to do close handle and I am using that close semaphore function. That is release semaphore. That is not close semaphore. So here I will simply put like press any key, so which is like understood. So I will just, oh my god, get char I will use, so that once you press any key or you press any enter key, then only this program will come to an end. Okay, so let me see if it works fine or not. Don't go with the name reader db, just go with the code which I have shown you. So here you can see like it will simply move ahead and it will simply wait for you to press any key, and I have pressed the key and it will come to an end. Okay, so here let me do one more thing. Here it's 5, so I'm just going to do one more thing. I'm just going to make it like 6. So 5 are the maximum and I'm making it 6 which are available. So what will happen? Let's see. Okay, semaphore not created. Why this happened? Because this available resource count can never be more than the maximum resource count. Okay, so it can be less than the maximum resource count, but it can never be greater than the available maximum resource count, right? This is the available resource count and the next argument is the maximum resource count. So if there are maximum number of 5 resources, then how can you make it 6? You cannot make it. You can make it 3, you can make it 4. This will work. If you want to see, it will work. It doesn't give any problem. You can see that it is working, but you cannot make it 6 or 7. More than the maximum count of resources, you cannot set it, right? And you can also not set it 0. Right? Again, you will get semaphore not created. And you can also see one thing. If I make 0 resources available, then what will happen? Just pause for a moment and just guess what could be the output, and then you can come back to see the output. Here you can see that no error came, right? So you can simply press enter and it will work. Why? Because this can be 0. 0 means that there are maximum number of 5 resources available, but none of them are available as of now. This can be a situation, suppose you are a writer thread and you want, or you can say that you are an initializer thread which is initializing the database, which is initializing some shared memory in your application, in your server. So what you can do, like until your shared memory is allocated, none of the other threads should be able to work. None of the other applications should be able to connect to that shared memory segment, right? So in that case, you can make it 0. And once you are able to initialize the segment, this shared memory segment, then in that case, you can simply release all these semaphores. Like here, if you want to release all these semaphores, release semaphore, then in that case, what you will do, you can simply press like, put like H semaphore, and then you can simply put like the maximum number of releases. So you press, you put it 5. So once you have pressed any key, then in that case, what will happen? It will release the 5 semaphores at the same time, which means that 5 threads which are waiting on this semaphore, they will be scheduled. Previous count I don't want to cover, so I have just pressed it now. So even this code will also work fine. It will not give any exception, any error, right? So I hope you might have understood the basic concept of using and initializing the semaphores. So in the next video, I will explain you some more things, and I will show you some more things that around this semaphore available resources. Then we will see that how you can use it and how these resources become available and not available. So till then, have a nice day and bye bye.